Okay, welcome. I think that right now it's time to start the meetup. Right now, I'm only seeing Richard. Welcome, because you are basically the only one here. Oh, there's Mark right there. Okay, welcome. I think this is the first meeting for the Tampa Bay PostgreSQL user groups in a while. So thank you for coming. And I hope that this meeting is useful to you. I know that you very likely took time from your lunch in order to be here. So hope that this is productive. So in this meeting, we're going to talk about optimizing queries in PostgreSQL, how to take advantage of the most advanced open source database in the industry. Okay. So a little bit about me, about the speaker. My name is Giovanni Martinez. I'm a senior database architect in KCS Technologies. I have about 10 years working with databases. I started working with SQL Server, but then I have been working with PostgreSQL for more than 5 years now, and it's become my go-to database. I also work with MySQL, MongoDB, and Cassandra. Although I'm a fan of PostgreSQL, one of the things that I like about PostgreSQL is that it plays well with others, so it gets along with other database technologies. So it's great. My blog is pgvirtuoso.com. That's my LinkedIn, pgvirtuoso, and my Twitter handle, PostgreSQL FYI. So that's enough about me. Let's talk about the elephant in the room, the blue elephant, Postgres. What is query optimization and why is so important? Oh, one thing I should mention before starting, if you have any questions, if you can post it in the chat, I'll gladly take a look at it. Okay, so thank you. What is query optimization and why is it so important? So basically, optimization is make your queries go faster, right? But what an optimized query is going to depend significantly on the business needs for your queries. What I mean is, for example, if your application is a basic blog, you don't need that much speed. So in a blog, maybe a query that takes 2-3 seconds is good. Maybe if you are in a company and you're running monthly reports and those reports take 1 hour to finish, that could be okay. But you can be in an IoT company where you process thousands, maybe tens of thousands of transactions per second, and a query that runs 1 second is too slow. So it is very important that you understand the needs of your business, because that's going to determine whether your query is running optimized or not. Long-running queries might cut undesired locks, bloating, and the dreaded wraparound. So because this is each one of these problems that I mentioned, it merits its own meetup. But if you have long running queries, basically you can block or affect the other queries that are running. And the wraparound, if that happens, that's basically an outage. So this is very important. On query optimization, I realized when I chose this subject that is a very broad subject. And after this, I'm gonna send you information, because I think I would like to make this a series, because it is something that people ask all the time, but it's something that it cannot be done in 1 hour. We need to make it significant. I want to divide it in multiple meetings so we can talk. So today we're going to talk a little bit about some indexing tips and a little bit of how PostgreSQL thinks. The first of all, and this is a warning, there's no magic trick. When I say that, because usually what happens is that someone that doesn't operate the database designs this huge schema. They create these queries and they just dump it on a DBA and make it work, make it go faster. It doesn't work like that. For example, if you have a query that requires joining 20 tables and gathers information on millions of records, and you do grouping and you do sorting, that query is not going to finish in a second because it's not possible. So we need to understand that if we have a need of that such speed, we need to take another approach. Though PostgreSQL can be very fast and it's one of the most performant databases in the industry. Now, when should we start thinking about query optimization? The very first moment that we write the query for the first time. Even when we are designing the database, we should start thinking about what queries are we going to run and should optimize. Ideally, that should happen, but experience is that another person designs the database and then we have to optimize it. Another thing is that we have to think about the uniqueness of PostgreSQL, and there's something that's very unique, and that PostgreSQL can take a hint. What do I mean can take a hint? One of the characteristics of, for example, SQL Server is that you can hint SQL Server into getting using a certain index. I think that there's a plugin in PostgreSQL that should allow some hints, but it's not from, I mean, it's someone that created that. It's not, the community doesn't, by design, they don't want PostgreSQL to use hint. They think that the optimizer should be able to make the decisions. And I want to show you what do they mean. Why do they design it like that? So let's, that's enough theory. Let's talk about a little bit of the demo. So here I'm using, I designed, this is a rough database that I'm using for inventories. That we have our product tables, inventory tables, companies tables. I have my relationships here, foreign constraints. So everything is there and it has data. Now, why do the community doesn't want to design the optimizer to use hints so you can force to use an index? Because sometimes not using an index is the best option. And let me show you. Look at this query, right? They are very similar. This is a very simple query. This is select start from inventory where date between, and there are two dates, right? The only difference is that this is the data for one date, and this is for about 4 years. But it's the same table. And if we take a look at the inventory table, let me show you. Here, this is the index for the column date. This is a B3 index, so it should work just fine, right? So if we do explain, I'm using data grid because I like these tools and graphics, so I can show you more better how to perform. So I'm going to use here. So I like to use the visualizations. So here, no surprise, Big Scan, it uses the date index in order to do the select statement. That's fantastic. Now, let's execute this. It should use, in theory, it should use the same index, right? Let's see. Table full scan. Why is that? Take a look at how many actual rows it grabbed. About 8,000, right? This table has about 10,000 records. So we're talking about 80% of the table. So Postgres, what it's saying is it's easier for him to just do a full scan, grab all the records, filtering, than using the index to grab all those records. And in this case, this is acceptable. This is good because this is more efficient. Because the selectivity, when the selectivity is high, it's better to do sequential scan. But when the selectivity is low, or when there's a reduced amount of records of that table, then SQL Server PostgreSQL uses indexes. All right. One thing that I wanted to mention, because I'm using data grid, but if you have pSQL, you can see this in when you want to analyze your queries. You can just execute. You can put this before the select statement, explain, analyze, buffers, and timing, right? And if you execute it, you get the results in text, and you can see it. One thing is that the records that are most to the left are the ones that are executed first. One note that you should be aware of: there's a difference between explain and explain analyze. So we can do explain like this, or explain analyze. And there's a huge difference, because when you do explain without analyze, PostgreSQL estimates the execution plan, but it actually doesn't execute it. If you do analyze, it will execute it. So if you're in production and you're not sure how that query is going to behave, don't do explain analyze, because you might log a table or worse. So, all right. So this query is very simple, right? Select, but it's not what we use. We usually, most of the time, we need data from multiple tables. I mean, that's why we use joins. So how can we optimize that? So let's take a look at this. This query is a simple query where we're grabbing company name, the product model, the amount of that inventory, the category day, the category name, and the date. And the word statement is between dates. We have an index there, right? So let's see how it performs. If we go here, explain, analyze, and let's take a look at here. So here, what we have, like I said before, if you take a look at the text, the ones that are most to the right are executed first. The ones most to the left are executed later. In this case, when data grid put this into the graphic, the ones at the bottom get executed first. So start with a series of bitmap scans, index scans, fantastic. But here we have full sequential scans, full table scans, sequential scans. Why is that? If we take a look at this companies, we see that it grabs 10,000 records. Once again, it grabs all the records. So why does it even bother to use an index, right? When the selectivity is so broad, it will not use the index. And we want that, because if it uses the index to grab all the records, it's doing work 2 times. It's twice the work. So no, it's not efficient. This is more efficient. Now, let's reduce the selectivity by filtering the company. Okay. Let's go here, explain, analyze. Now, let's take a look at here. Now, we still have here a full sequential scan of the warehouses, but we're going to take a look at that later. But we have bitmaps index scan, index scans, index scan, and another index scans. Why? Because you see that it grabs one row, and one row. No more rows. So when the selectivity is a small subset of the table, then it decides to use the index. Now, let's take a look at this sequential scan of warehouses. When we take a look at here, the company ID on this table is filtered. right? And when we take a look at this, so company ID is a foreign key for location ID, the table location column ID. So the problem is that when we set up foreign constraints, they don't automatically create indexes. If we take a look at how many indexes, company ID doesn't have an index. So we come here and we create the index. And if we do explain, and let me show you here. Boom. The full scan is gone. So there's the bitmap index scan, everything is index scan. And this is much more efficient. On more complex select queries, sometimes it's better not to use queries, and we can learn that later. But in this case, using index is very efficient for these queries. So we have to understand one thing also. Queries, indexes are not free. They have a cost. For every index you create, you are adding a right, meaning if you have a table with 5 indexes, every write, every update, every delete is gonna multiply by 5. Meaning it's not only 1, it's gonna be 6 writes, 6 deletes, and 6 updates. If you have a table with 10 indexes, yes, now you have 11 insert, 11 updates, and 11 deletes. And if your database is busy, now you're going to have an auto vacuum process that is going to be extremely busy. And that can cause performance issues. So we can't use indexes just because we can. And I'm going to put an example, right? Because there's one way that we can optimize for reading even more. We can create this index, right? Which is, if we go to the table companies, it is a small table. We have ID, we have name, and ID is the primary key. So we have, with all primary keys are indexed. And they are unique constraints. Now, if I come here and I create this, because I can create multiple indexes in the same column, there's no rule against it. So I can create this index, and this time I'm going to use, this is a feature that PostgreSQL added in recent versions, that you can add extra information inside the index so it doesn't have to go to the table. Let me show you. So I'm going to create this index, right? It's gonna index on table companies, on ID, and it's gonna include the name, the name column. Okay. Now, if I now do an explain analyze, and let me go here. So we have a gain because here we have an index scan, and it's an index-only scan. So when we read that, we don't go to the table. They grabs from the index all the data that it needs, so it reads faster. But each index is its own data structure. What that means is that I created 2 copies of the table compounds. And maybe in a small database like this, it's not a big issue, but in others, it's going to be a big issue. And also, so because like I told before, every update, every write, every delete is going to be multiplied by 2, right? It's going to be the table and the indexes. And that can cause performance issues. And when we see what we gain here versus PostgreSQL using the primary key and grabbing the name, we didn't gain that much because this is a small, we gained something, but it's not that much. What we have to sacrifice in writing is so much more than what we gain in the reading performance. So it's not worth it in this case. So let me clean up this. Okay. Now, one thing that in order to be master optimizer, virtuosos of the optimizer, we need to understand that although the most common index is B3, is not the only index that we have. So when you create an index like this, and you don't specify like using B3, it by default uses B3. So B3 basically divides the data into layers, into leaves, and it's linear. So we can use B3 indexes for equality, but we also can use it for ranges. We can use it for greater than, less than. But some cases, we can use another kind. Today, I'm going to talk to you about one of them, is the hash index. The hash index is very unique. And what happens is that it takes the value of the columns that you assign to the index, and it doesn't save the value of that column. It saves a hash, which is smaller, more compact, and is faster, because now what it's going to do is that it's going to compare the value, it's going to hash the value that you're going to looking for, and it's going to compare with the index. It is much, much faster. But there's the caveat. It only works with equality. The reason why B3 is like the go-to index is because it's very versatile. Like I said, we can use it for ordering, for sorting, for less than, greater than. You can use it for you can do inclusive indexing, so it doesn't have to go to the table. But hash is a very specific kind of index. It only works on equalities. Like for example, here, if I come here, create, right, and I created using hash, and I come here, and I do explain analyze, It's going to use that. It's going to use that index, and it's going to be faster because it's using hash and it's using equality. But if I try to, and I mean, it doesn't make sense in this case, but just for example, greater than 1, and I do an explain analyze, it's going to do a full sequential scan because it cannot use the hash index. So it is useful for certain for certain cases, but not for everything. Okay. Let's clean it up. Okay. One of the neat tricks that we can do with PostgreSQL that is very unique, make PostgreSQL unique, is that we can use multiple indexes in the same table in the same query. And not many databases can do that. Take this query, for example, right? This is querying the warehouses, and it's filtering on company ID and location ID, right? Right now, let me see if I'm correct. I'm gonna do a sequential scan. Yeah, because there are no index. Now, so let me create this. This is a hash index for location ID. And let me recreate this one, the company, because I think I dropped it before time. So, and now let us do an explain analyze. If we take a look at this, it uses both index scans, both indexes, and then perform it performs a bitmap scan. So this is very efficient, and not many database engines can use multiple indexes in a single table. Now I'm going to clean up here. There's another way to do this, yeah, and it's creating an index with multiple columns, right? And when we created that, and now if we execute this, we do explain analyze. This is so efficient because only did an index scan. So in this case, a single index with two columns is more efficient than using two separate single indexes. Now, remember what we talked about before. Having multiple indexes have a cost. If you have a table and you know that on the word statement, you use 5 columns, and you always use 2 of 5 columns. If you create an index for every possible combination of 2 columns, you end up creating 10 indexes. Versus if you only create 5 single indexes, Postgres can use 2 at a time. Using a single is more efficient, but it's gonna, the price of having 10 indexes with 2 columns each one, it might be too high. So it's better to have, in that case, it might be better to have 5 single indexes. Indexing is an art. And like I said, you need to have you need to test it out. And one thing that, I don't know if I mentioned this, but one thing that we need to understand is that when we do tests, we need to have a data set very similar to production, right? Because like we saw at the beginning, when there's a difference between selectivity, Postgres behaves differently. So if you have a database in your laptop, which you can have a database in your laptop, you can have PostgreSQL in your laptop, but Postgres is very light. But when you can create the same schema, but when you do the test, when you do the explain, it's not going to behave the same, because Postgres, when it creates the execution plan, it's going to take into consideration selectivity of the data. It's going to take into consideration the memory condition, the CPU, even the IOPS speed, the IOPS. So it's not going to be a reliable test. It should be as close as production as possible. Now that we checked that out, let's keep going, and let's keep talking about compound tables. So if we take a look at this, let me see. Oh, I already did that. Yeah. So let's do cleanup. Okay. Now let's keep talking about these indexes, right? Or using multiple indexes. And this is a second example. If this is on the products, and this is on the model and the category ID, right? And the products table. If we do an explain right now, full sequential scan, no surprise, because we have no index. So let's create the index, 2 indexes. And now let's do the explain analyze. And no surprise, 2 bitmap scans. Great, perfect. But now, in this case, because this is such a small table, and I don't really need to have this separately, it might be better to do this, right? To create an index with the 2 columns and include. And oops, I have to execute this because I'm creating. Okay. And now, if I come here and I do an execute, explain, analyze, this is great because now we have an index-only scan. So with an index-only scan, you gain a lot of performance here, and it reads faster. So that's what we want. Let's clean it up And as the last demo, we're going to talk about partial indexes. So indexes are data structures, and they occupy disk space, and they requires I/O. But sometimes we have a specific needs, so we don't have to index the whole table, only partial table. So we can, in this case, let's say that we query constantly. We have a specific need for category 100. So we create an index on products category where category ID equals 100. So instead of the whole table, it will only index category IDs 100. So we create that. And if I do this, it actually uses that index. And this is a smaller index. It's less write and update and delete, and can help you optimize the database. So let's wrap this up. Okay. Summary. You gotta understand how PostgreSQL thinks. There's a book I recommend, PostgreSQL Query Optimization. I can ping it to you later. I have met the author. She's a true guru of Postgres optimization, Dr. Henrietta, and I'd say it's a must read. And also the PostgreSQL documentation is very rich with this, how it behaves. Like I said at the beginning, I want to create make a series of optimizing, because there's a lot to talk about optimization. This is just a small bit. We're talking about analytical queries, how we can tweak the server for better optimization. So many things that we need to talk about this. And another thing is that we talk about is to use the right kind of index. Sometimes, although B3 is the go-to, and usually you can't go wrong with B3 index, know that there are others that might be good for your use case, for a specific use case. And finally, make good use of covered index and partial index in PostgreSQL. All right. Are there any questions? Okay. I don't see anything in the chat. Well, thank you. All right, well, let's wrap it up. Thank you for your time. I hope this has been useful to you, and I hope that we can do this more often. Thank you very much. This meetup has been recorded, and I'm gonna make it available. I think I'm gonna send it to the community. I think the PostgreSQL YouTube community YouTube channel is gonna upload it. So as soon as I get this in YouTube, I'll let you know. Thank you very much, and have a good afternoon.